Have any of you noticed how big the Saturn V rocket is? I mean, being 363 feet tall and weighing 6,172,943 million pounds, and might I add making 7.6 million pounds of thrust. So why do these rockets need to be so big? Well, the rocket is actually 85% fuel. The rest is structure and payload. And like everything on the planet, there's math that can explain everything. Even if you think of a piece of wood, there are energy and forces and all kinds of things inside that one piece of wood. So looking at the Saturn V rocket, the astronauts, the lunar module, the command module, and the service module, even the frame of the whole rocket is considered payload. The most important part of this rocket is the astronauts. And where are they? Well, they're in a little teeny tiny command module way up at the top. And the rest of the rocket is mostly fuel. But why do they need so much fuel? The reason for that is you need a perfect amount of fuel regardless of any type of payload to get it to orbit. But there's a problem with that. As Neil deGrasse Tyson states, the weight of the payload is not the only stuff that you are bringing to the moon. It's also the weight of the fuel you haven't burned yet. So what's going to lift the fuel that's taking the astronauts to the moon? That means you need more fuel, but what lifts that fuel? You need more fuel. And it just keeps adding up and adding up. So really this will continue on forever. And if you could guess, that is very hard to calculate. So to figure out this problem, we use something in math called calculus. And I'm no calculatician. Calculatorist? I'm no mathematician. I am just a high school student. But calculus was actually designed to solve these types of problems. So the equation that we need to solve all of these problems is velocity equals exhaust velocity times natural logarithmic function times initial launch mass divided by final or dry mass. Now this equation might seem simple to solve, but this is just the final step. There are many more steps to find each variable in each section, and even adding the natural logarithmic function makes it so much harder. I mean, why does the world have to be so hard to understand? So what we can infer using good old calculus is that the amount of fuel you actually need for each pound of payload grows exponentially. Now another problem when designing rockets is what happens when the tank becomes empty. Once a fuel tank is done, it's done. You can't use it anymore. So Wernher von Braun and his team started designing rockets with multiple stages, which became the invention of multi-stage rockets. Hence we see 3 stages on the Saturn V. The first stage, second stage, and the third stage. And as you can tell, they each get smaller and smaller, because the second stage doesn't have to do as much work as the first stage, because it's already going fast enough. So SpaceX is using this equation to their advantage. They're using it to have a little bit of extra fuel left in their boosters, so that they can guide the rockets down, land them, and then reuse them. So this reusability is imperative to save our space program. It will save a ton of money. So overall, this equation really tells you how big the rocket needs to be. And calculus allows us to make this equation perfect, and that is how we have been doing it ever since the beginning of the space program. Thank you guys so much for watching. Click over here to subscribe, and hey, there's a couple more videos for you to watch. I'll see you next time.